All right, let's dive right in. We're going to tackle a question that sounds, well, kind of impossible. How on earth does a rocket move in the complete emptiness of space? I mean, really think about that. But stick with me, because by the end of this, you'll see it's not some crazy science fiction. It's just really, really beautiful, simple physics. So, to really get this, we've got to wrap our heads around the main problem, the paradox of it all. See, here on Earth, everything moves by pushing against something else. It's just how things work, right? Your car's tires push against the road. A plane's engines push against the air. Even when you swim, you're pushing against the water. But in the vacuum of space, there's just nothing. Absolutely zip. And that brings us right to the big puzzle. If there's no air, no ground, literally nothing to push off of, how does a rocket go anywhere? It feels like it should just be stuck, right? It feels impossible. And you know what? For a long, long time, this very question had scientists completely stumped. Okay, so right about now, the most common guess usually pops into people's heads. You're probably thinking, well, they're just like super powerful jet engines, right? Pushing against the air behind them. Makes sense, but that's not it. Not at all, actually. Let's just get this out of the way, nice and clear. Rockets do not push against the air. They don't need an atmosphere to work. In fact, and this is the crazy part, they actually work better where there's no air at all, in the total vacuum of space. So, if they're not pushing against the air, what in the world are they pushing against? The answer is, well, it's simple and honestly a little weird. Rockets push against themselves. Yeah, you heard that right, themselves. So how is that even possible? It all boils down to one single elegant universal law of physics. And I mean everything. Every single thing about how a rocket works, from a tiny little firework shooting up on the 4th of July to the most massive, super heavy booster lifting off the launch pad, it all comes down to this one fundamental rule of the universe. And that law is, of course, Newton's third law of motion. Now, I know you've heard of it before, we all learned it in school, but what you might not realize is that this single law is the absolute foundational blueprint for every single rocket ever designed. Yep, you know the one. For every action, there is an equal and opposite reaction. It sounds so simple, right? Almost like a cliche. But for a rocket, this isn't just some dusty old saying from a textbook. It is the entire instruction manual. Let's make this super simple. Picture this. You're an astronaut. You're floating in space, perfectly still, and you throw a heavy wrench as hard as you can. What happens? Well, the force you use to throw that wrench forward, that same force pushes you backward. The wrench goes one way, you go the other. A rocket is doing the exact same thing. It's just that instead of a wrench, it's throwing a massive amount of super hot gas out of its back end at incredible speed. Okay, so the principle is simple enough. Just throw stuff backward really, really fast. But how does a rocket engine actually do that? Well, to understand the how, it helps to think of the engine for what it really is. That's right. At its very core, a rocket engine is basically an explosion machine. Seriously, its one and only job is to create, contain, and control a continuous, unbelievably violent firestorm. And to pull that off in the cold, empty vacuum of space where there's no air, it has to pack its own lunch. And that lunch has two main ingredients. First, you've got the fuel. That's the stuff that burns, like rocket-grade kerosene or liquid hydrogen. But here's the catch. Fire needs oxygen to burn. And, as we've established, there's zero oxygen in space. So rockets have to bring their own oxygen with them in a liquid form called an oxidizer. And this, right here, is the key difference between a rocket engine and a jet engine. A jet engine is like an air-breathing creature. It has to suck in huge amounts of air from the atmosphere to mix with its fuel. No air, no go. A rocket engine, though, it's totally self-contained. It brings its own air, that oxidizer, with it. And that is the secret sauce. That's why it works perfectly fine, even better, in a total vacuum. All right, so let's put all the pieces together. We've got the fuel, we've got the oxidizer, and we've got Newton's third law. Let's walk through the step-by-step cycle of how this controlled explosion creates that powerful forward push we call thrust. Okay, here's how the magic happens, step by step. First, incredibly powerful pumps force the fuel and the oxidizer together inside a space called the combustion chamber. That's the mix. The second they meet, they instantly explode. We're talking a continuous controlled firestorm. This firestorm creates insanely hot gas that builds up unimaginable pressure inside that chamber. That's pressurize. Now, all that super hot, super pressurized gas has only one way to escape:
out the back. So it's forced out through the engine's nozzle where it starts to accelerate like crazy. And finally, that backward blast of gas, that is the action, creates an equal and opposite forward push on the rocket. That's the reaction. That's thrust. And you know that nozzle at the end? It's really the unsung hero of the whole operation. It isn't just a simple funnel, no way. It's a brilliantly designed, precisely shaped piece of engineering that takes all the chaos of that explosion and focuses it into a single, directed blast. It accelerates that exhaust gas to, literally, thousands of miles an hour. And the physics is simple. The faster you can shoot that gas out the back, the harder the universe kicks your rocket forward.
So after all this talk of firestorms and hypersonic gas and combustion chambers, you might be thinking this is some kind of crazy next-level physics. But it's really not. In fact, I guarantee you have seen this exact same principle in action a million times before. Because it's the exact same physics that makes a simple party balloon fly all over the room when you let it go. Think about it. You blow it up, creating high-pressure air inside. When you let go, that air rushes out the back, that's the action, and it pushes the balloon forward. That's the reaction. A $1 billion state-of-the-art rocket engine is literally running on the exact same principle as a 10-cent balloon. So in the end, one of the single greatest achievements in all of human history, actually leaving our planet and touching the cosmos, is powered by one of the simplest, most fundamental rules in the entire universe. It just makes you wonder, doesn't it? If a law this simple can conquer space, what other huge, seemingly impossible problems out there are just waiting for an elegantly simple solution?